So we made the table.
Yeah.
We were on this one, and he's saying that D. It was molar conductivity against this under root thing. Have you plotted it?
Yeah, I've plotted it.
The complete plot. You got a straight line?
Yes.
8.94, 8.94 and 0.154. 8.94. Is it coming a straight line?
Yeah, it is.
It is coming a straight line.
Mm.
Variation is coming. Then he says, circle one point on the graph that you consider to be most anomalous. The conductivity meter was correctly functioning. Suggest one reason why this anomaly may have occurred during this experimental problem. So which point is anomalous? My case, this second last point is coming anomalous.
Yes, me too.
So what is the what are the coordinates of this? 17.9 and 0.368.
Mm.
Suggest one reason why this anomaly may have occurred during this experimental procedure. What may be the reason? Maybe conductivity is recorded wrong, but he says meter is working right.
So maybe the concentration of ethanoic acid.
Okay, can you repeat the statement you are suggesting?
The concentration of ethanoic acid.
Concentration of ethanoic acid is wrong, is recorded wrongly, or we made a wrong concentration solution. You mean that?
Mm.
Ethanoic acid solution was was not made. So we didn't make the solution in correct concentration. The equation for the line of best fit is shown. This symbol V infinity is 3.91 dm square S per mole. Use your graph to determine the gradient of the line of best fit. State the coordinates of both points you used in your calculation. There must be selected from your line of best fit. Give the gradient to through three significant figure. So we can find 2 points. So my 1 point is coming 0.5, so 0.5 and 0.0. One point is coming this. Second point, if I go on my maximum position, I can read this point, which is coming at 0.414243. 0.43, and it is coming here. This will be 24. So 24, 0.43. 24, 0.43. So let's find the gradient then.
Mm.
0.5, 0.0, 24, 0.43. If we find the coordinates like this,
It will be 0.0183.
as per my points or as your points?
Yeah, no, your point.
Can you please repeat the answer?
Yeah, 0.0183.
Okay. Hmm. Okay. Determine the acid dissociation constant of ethanoic acid. Include units in your answer. So how we do that? Dissociation constant is, should
They
we
give
apply the linear law here or something like that? What the acid concentration? Because we have to use the gradient. So should we apply linear law working? I mean, should we take this equation and rearrange it for the linear law y is equal to mx plus c Now this is the equation. So what I was thinking that if I can rearrange it and see what gradient is there, my graph was plotted against molar conductivity, this inverted Vm upon this. So what should I do now? I'm thinking to rearrange the equation. I'm going to take the under root thing on the left hand side. Look, this is the thing. Then I will try to convince examiner that the left hand side of this equation is actually the gradient.
Mm.
So gradient is equal to gradient. I've shown the working. Gradient is equal to this symbol under root Ka. Let's make Ka the subject. My gradient was 0.01, 0.0183, 0.0183 upon, what is the value here? 3.91.
Yes.
Now look at this. So can you help me also get my answer also?
Yes. It's coming to be 2.2 times 10 to the power minus 5.
He says give the unit also. We have the unit of the gradient. So we can simplify dm 0.5 s mole 0.5. And what is the unit of this? Unit is dm square s per mole. So let's try to simplify the unit here.
Mm.
The unit for gradient is dm 0.5 s mole minus 0.5. dm square s per mole. Look at this. Now simplify this. We can cancel S. How much will be dm 0.5 minus 2?
Minus 1.5.
Mole.
Shouldn't we also include the units of concentration?
You're right, but actually, I was thinking we should put a square on it. That's all. No, actually, we have our final formula is Ka is equal to gradient upon this symbol M. Actually, the root is already covered in it. Now, the only thing
Mm,
which I feel we should include the power.
okay.
So when you put power on it, now how much is 1.5 into 2? It will be minus 3, and it will be, I'm getting this, dm minus 3 into mole. Mole power will become 1.
Yes.
So we have shown our working, and we already know that it's a acid dissociation constant, but I have shown all the working, and I can justify that this answer is mole per dm cube. Shown all the working, mole per dm cube. Now, the student repeats the experiment with propanoic acid. The numerical value of the Ka of propanoic acid is experimentally determined as 1.28 into 10 power minus 5. The theoretical numerical value is this. Comment on the validity of the experimental result. Assume the maximum total percentage error from the measurement made is 6.5%. Oh. So we have a theoretical value, we have an experimental value. So should we just subtract it? I mean, the validity of the experimental result isn't that. So this question is looking to be a pure mathematical question, G part.
We should calculate the percentage error.
And we should later compare it.
Yeah.
Later compare it with the tolerance level given. So let's write down the formula. Percentage error is equal to error upon 2 value into 100. I can say 1.34 minus 1.28 into 10 power minus 5 upon true value is 1.34 into 10 power minus 5 into 100. We have to solve it. 10 power minus 5, 10 power minus 5 will eventually cut. See how much percentage we get here.
It will be 4.5%.
4.5%. Result is valid as 4.5% is within 6.5%. So this paper is completed.
Mm.
So we have to start a new paper